All right, everybody. It's top of the hour, and since this is like I said, an action-packed class, we're not going to wait a whole lot longer. People can join in, and they will get to see what they see. Let's see. Yep, view the lobby. All right. We're going to admit everybody in. Welcome to Lightware's USB Masterclass. We're going to go ahead and get started. I'm Jason Tirado. I'll be doing the presenting today. We've also got Tyler, who's helping me out. And Tyler is going to be answering your questions in the chat window. If you have anything you want to communicate with us, use that chat window, okay? We can't really allow everybody to be speaking at once. So if that's the best way to communicate with us. Usually you would have Allison. Today you got me. We're going to have the ability to give you some Avixa credits. And so you can get some CTSRU credits by taking the test. Tyler is going to drop the link to the test into the chat. And so you guys can take it. I took it this morning. You have to pass with 7 out of 10. I'm proud to say that I passed. Once you do, you'll receive your certificate of completion. You can get your certificate, submit that to Avixa for credits. A lot of those details will be shared with you in addition, so just keep an eye on that, but that's coming soon. You get one CTSD for today's agenda. Today, let me go back. Today, we're going to cover a lot of information about USB topology. We're going to cover device classes, hubs, host switches, extension challenges, USB-C connectors versus USB-C standards or USB standards, how video is delivered over USB-C, data, cabling, and finally, the Lightware Taurus line of products. That is what is on the agenda. I'm just going to make sure that everything is smooth here. And Tyler, if you see some questions or something, I'm going to turn the meeting over to you every now and then. I'm just going to pause and you can unmute your mic, and then you'll be able to answer questions that come up. So that's the way we're going to handle that. I won't wait till the end. I'll give you a couple of chances to cover some stuff while we're doing it. Here's an idealized picture of the perfect room, right? All the participants have equal access to shared peripherals. That includes the camera you can see under the display, the microphone, the speakers. Those are all USB peripherals. And everybody walks in and they're able to share their content easily. There's no cables in this particular picture, but so it would be quite amazing if everybody could connect just like this. But the point is they can all use the shared peripherals in the room easily. That's really what we want to do. And this idea was born out of an actual story from an end user. Years ago, the CEO of Lightware and we visited a large end user, and they told us they were going to build a bunch of Teams rooms, but users with Surface tablets needed access to the shared content using USB-C, and ideally they'd also be able to access the shared peripherals. And at the time, there were no devices that did that included USB host switching with audio, video, Ethernet, and power. But we developed the first product range to solve this problem called the Taurus. And right now you can see this problem sort of presented in this slide here, where all those USB peripherals are attached to that Teams room PC in the room going through that USB hub. So all those peripherals are attached to that same PC. But if somebody walks in, let's say they have an invitation from a different platform, they've got content they want to show, ideally they can share their content, they can also get power, and they would also be able to host those peripherals so that they could use shared aspects of the room. If they don't do it, then it's going to be something like this, where maybe they get their content on the display, maybe they don't, but with the integrated camera in the laptop, people who want to join a collaboration room could all stand around and look at the camera. And that's not a very efficient way of working. It doesn't really allow shared peripherals to be shared in the way that they should be. Ideally, we could bring in to this room, bring your own device or bring your own meeting style laptop. And with a simple connection using that USB-C, you would see audio, video, USB data, Ethernet, and power all delivered to this new guest that just walked into the room. And keep in mind that when you connect, we would also want all of these signals to be independently switchable. So we would decide when the content from the PC was going to go to the display, when those peripherals would be attached back to this new host, when the audio would be sent, and how we would de-embed the audio if we needed to, whether or not Ethernet was going to be traveling to the corporate network over the Ethernet switch, or whether we were not going to allow that to happen. All of those things should be completely controllable in this environment. I'm going to take a little break here and just make sure I've got everybody into the meeting that needs to be in. So I think we're doing okay on that. And USB basics. So in order to get from point A to point B, in that perfect room, we've got to learn some basics ourselves. There are many form factors out there. There are standards, and in general, there's a lot of confusion about what is involved in USB technology. But today we're going to provide some insight and some information about it so that everybody understands what it is that they're seeing in this USB world. USB originally got started because there were many, many connectors for many, many different types of devices. The evolution of connection ports on computers was serial ports, consoles, drivers, parallel ports, and that meant that many, many adapters were required. One of the main drivers of this USB-C adoption was when the European Union several years ago made it mandatory for all laptops, smartphones, and tablets to have a unified power connector. Basically, the European Union was sick to death of all the different power cords that were coming with all these different devices. And so they mandated that if you were going to sell to the European Union, actually beginning, I think, in 2025, you had to have USB-C minimum as a power provider. But large companies like Microsoft and Intel and Apple decided that they wanted to sell to the EU, and so they all adopted that USB-C standard for power. And it was originally developed by a man named A.J. Bott, who brought the idea of a universal connector to life. When you see USB as it's developed, this story is really one of increasing bandwidth. And you can see right there on the far left side of the slide, back in 1996 with the original USB 1 introduction, it was 12 megabits per second. And that's fine if you're just doing keyboards and mice, basic peripherals. They don't need a lot of data. It was improved in 2000 dramatically up to 480 megabits per second. And it was still a half duplex communication, though. That's unidirectional bandwidth. That means all the information was going one direction at one time. If you get to USB 3, then two big things really start to happen. Number one, full duplex. That's bidirectional communication. And you increase the bandwidth from 5 gigabits in some generations to 10 gigabits to 20 gigabits, all the way up to things like USB 4, which could actually have 40 gigabits per second along with Thunderbolt 3. And so again, this story is about increasing bandwidth, and the need for more bandwidth especially became prevalent when we started using video delivery over USB connectors. Okay, but that brings up a very important point, which is one of the biggest sources of confusion here with USB is the difference between the connectors and the USB standard itself. So on this slide, what we're trying to show you is that there are many different types of USB connectors, like that type A for your peripherals or type B for your host. You've seen that probably on your computers and peripherals today, along with some of the variants of those mini A, mini B, and micro connectors too. And super speed type A came along around 2008 with additional pairs so that we could get the full duplex communication and increase the bandwidth. And super speed type B, again, more pairs for connecting the bandwidth. But if you look down at the bottom of the slide, what you see is the USB-C form factor is applicable across all the different USB standards for speed. So this is two different things. And as we go along, I'm going to keep repeating it until you're probably sick of it, but it's a very, very important point because we can have a standardized connector like USB-C, but that doesn't mean that it automatically means you're getting 40 gigabits to 20 gigabits, 10 gigabits, or 5 gigabits. That depends on the USB protocol that's actually going across the connector. And so we just want to make sure that we don't confuse the connector with the standard. This slide is kind of a different way of looking at it. It's a simple overview of all the USB standards and their related speeds or bandwidth. And so remember, we talked about USB 1 with less than 5 gigabits. It was down to originally 12 and then 480 megabits per second. Then the USB 3 family came along, and as you can see along the table there on the far left, speed started really increasing. You've got 5 gigabits, 10 gigabits, 20 gigabits. Now, I'll just give you a note. Most peripherals today will still operate at USB 2, even cameras and such. Even though 480 megabits per second might not seem like a lot, it actually is quite a bit, and it is actually fine for many, many types of applications. They did change the naming convention along the way. So you can see right here, we had the original names of these, and then they had the logo that was also associated with it. And then what people call it today is USB 2, right? And USB 3, 3.2 is kind of the way that people call it, even though there's different generations. And so this is the versions and speeds, and you can see the speeds called out there. We're going to come back to that quite a bit. It's going to be on the test, so that's why we're saying it again and again. There are some other different variants of standards. We're going to talk about two of them. One is Thunderbolt. So Thunderbolt 4, what is it? Thunderbolt is a high-speed protocol that dynamically allocates bandwidth between data and video depending on the application. It was originally developed by Intel and Apple, which is why Thunderbolt 3 was initially more common in Mac systems, and sometimes you could have compatibility issues with PCs. Today, Thunderbolt 4 and USB 4 share the same underlying protocol foundation, which improves compatibility across devices using USB-C connectors. Thunderbolt was actually quite helpful because it did push USB technology towards higher bandwidth and unified connectivity. So you can see in this slide here some of the details about the Thunderbolt 4 and some of the things, especially the bandwidth here. These 40 gigabit per second on Thunderbolt 3 and Thunderbolt 4 are it's quite a lot of speed. How do you achieve that speed? Well, you got to have enough pins. If you got enough pins, you can get the speed across. This is the slide where we really want to emphasize the difference between the half duplex communication required for USB 2 and the full duplex communication that is necessary for USB 3. It's a big difference. 480 megabits on 2 pins, or up to 10 gigabits and 20 gigabits per second, and a full duplex connection. And even though some of these connector types looked familiar and looked the same, they were not the same. As you can see here, this Type A connector had 4 pins, and this super speed Type A connector actually added some pins. So it could be backwards compatible in terms of plugging in, but it had additional lanes for more data and full duplex communication. And the same thing happened with the Type B connector as well. When we get to USB-C, USB-C was a much more advanced connector design. With 24 pins. And unlike some of one of the idiosyncrasies of the original USB connector was that it had to be in the right orientation. It was a little annoying, and I think everybody out here probably remembers it and even deals with it today. But USB-C, fortunately, is fully symmetrical and reversible. It doesn't matter if you've got 2 USB ends, whether you're plugging one side into the host and the other into the peripheral. That's okay. Also, it doesn't matter which way you plug it in. It doesn't need to be upside down or right side up. It is the same throughout. And that's a very, very big advantage of the USB-C connector. Plus, it's got the ability to send both the USB 2 and the USB 3 in a full featured configuration. So this is the actual USB-C connector itself. You need to know about that. But remember that just because the connector connects, that doesn't necessarily mean that the cable itself has every single pair connected. And that's a big frustration point and a big confusion point. So just because the USB-C thing will plug in correctly, that doesn't tell you anything about what's actually going on the cable. GPMI is a proprietary protocol that's fairly recent. It's introduced from China. It uses the USB Type B and proprietary Type B connectors. It does have increased bandwidth It's an emerging technology. Right now, I would say it's not that widely deployed. I wouldn't necessarily spend a lot of time worrying about it, but it is engineered for high performance AV demands. If you're using the Type B connector, you can get HDMI 2.1 and DisplayPort 2.1 speeds over it. The Type C connector actually delivers up to 96 gigabits per second, which is almost double the USB 4 standard of 40 gigabits per second. There's also some power that it gets supported on the GPMI, but again, it's not super widely deployed right now. This is really just more for your information about what's coming. I'm going to pause just for 1 second. Hey, Tyler, is there anything in the chat that we need to address right now? Anything that you want to talk about in front of the crowd? Tyler? Well, I'm going to take your silence as that we're okay. Oh, all right. Well, let me see if I can find you here, Tyler. Hey, Tyler, I think I just allowed you to have your microphone, so you might be able to unmute
Yep.
now. You want to unmute yourself?
Yep. Can you guys hear me?
I can hear you.
Sweet. So the one question that a couple of people asked in the chat, I wasn't 100% sure on this. Is there going to be like, are we able to send out this PowerPoint or is
Yeah.
that something? Okay.
Yep. No problem. All the people, everybody will get access to the content.
Yeah. And then Matt, I was just looking at your question in the chat as well. That this one probably comes a little bit later, so I will be messaging that right now. It's kind of like a little bit ahead of where we were at right now. So
Okay. All right, cool. Well, you go back on mute. I'll go back to sharing my screen over here, and we'll continue with the show, okay? USB topology. So what is USB topology? Well, it's the hierarchy of USB connections from the host to the peripherals. The host is always at the top. That starts the communication, initiates it, and each USB port on the host has its own topology, and it's structured in what we call tiers or hops. And each device or hub will add a tier or a hop in the system. Now, this is a very important point. You can only get 7 hops before signal degradation and latency makes it too much for the devices to have a consistent performance. And so some of you out there might have even seen this in the real life world where you'll plug a bunch of things in, and at some point, things are intermittent or they're not working properly. Here's a diagram that kind of shows you a way to think about the way this is constructed. Usually you have a laptop, could be a Windows, could be a Mac, but that is your host. And the host has a USB a port on it. And usually there's a built-in hub inside the laptops. Sometimes your laptops, usually Windows, takes up 1 tier, and Macs almost always take up 2 tiers at the very top of this pyramid. If you plug into something, could be a USB hub or like a docking station. Depending on the configuration of that docking station, you could be adding another. You'll definitely be adding at least one more tier, and you could possibly be adding a second tier as well. Then you get to your peripherals. So if your keyboard gets plugged in or you got a web camera, you're going to plug those in, and those will occupy that 5th tier. So this is the way things add up, and you have to keep an eye on how many tiers that you actually have, because if you start to exceed the 7-tier maximum, the latency will be too much, and you're going to have intermittent problems. One of the things that the way this manifests itself is that people start plugging in devices, just like in this slide here. They take their docking station, then they use their extension cable, then they've got a 7-port hub, and then finally they plug in the Rally Bar Mini. And if that has as a composite device 2 tiers, they're over the 7-tier limit. They don't know it. They don't know why, but suddenly things are not working reliably. And maybe they go back and they remove the docking station, and then suddenly everything works. And then they think, oh, well, it's the docking station that was the problem. But it was not the docking station that was the problem. It was just that they removed it that made everything work. If they went back and removed the 7-port hub or the extension cable, they would get the same results. So it's important to know how many tiers you're designing into a system. And so how do you know? Well, you can talk to the manufacturers. You can try to make an educated guess, or you can use some software tools. As we're going to go through some of these common devices, we've just learned over time about how many tiers these things take up. For PC, it's usually 1 or 2 tiers. Macs are almost always 2 tiers, so you can just count on that. If you've got an I/O device like a mouse, a web camera, a flash drive, those are generally 1 tier. 2 or more integrated functions into a web camera that includes microphone and speaker could be 2 tiers. So just be aware of that, because these are composite devices that act in more than one way, and so they're going to take up 2 tiers. If you've got a 4-port hub, that'll add a tier to your system design. If you've got a 7-port hub, that would add actually 2 tiers to your system design, because they're actually based on 2 4-port circuits. And the way that works is you've got a USB hub inside the computer. That's your source up at the very top, the host computer. And then down below, there's an internal hub that's been connected to. But if it's connected to another hub, that hub could be composed of 2 4-port hubs. And so now it's actually occupying 2 tiers. Sometimes people have composite devices like a keyboard with a hub built in. And again, if you've added that hub, it's not just the keyboard anymore. Now you've got the hubs, and so you're going to have 2 tiers that happen as well. So now that we understand that there's different USB devices and they consume different amounts of hops or tiers in the topology, we're designing a room. What do we do? I mean, what do you actually do? How do you know what's going on? Well, using a Windows-based PC, you can usually get away with this scenario, right? You've got a host, your PC laptop's going to take 1 tier. You can go with a passive USB-C cable to get yourself a little extension. That's not going to add any tiers. You could get to something like the Taurus. The Taurus can consume 1 or 2 tiers, depending on which Taurus model you buy. If it's the standalone Taurus, that's 1 tier. If it's the extended version of the Taurus, that's the TPX version. Point-to-point version, you're going to get 2 tiers, because we're going to have the receiver involved. This is sort of an older diagram that would show an external USB extension over Cat cable, and then your camera right there is going to be 2 tiers. So if you're okay, you're okay. But if you're not okay, you're not okay. So how do you get to be not okay? Well, somebody shows up and plugs in with the Apple. If you were at the limit before, right, then this is going to potentially put you over, and you're not going to get reliable communication. So you need to know when you're implementing these things and when you're designing these things, how many tiers are in your system. It's not always obvious. And so what can you do? Actually, one of the things you could do is you could come to Lightware. We actually developed a software tool. It's available on our website. You can go take a look for it. Maybe we'll drop a link to it. If Tyler wants to look for a link to it, he could drop it in the chat so that people could go access it on our website. But this is a Lightware USB expert software. And when you look at this image here, what you see is somebody running this on their computer. It shows the root hub. It shows the tier 2, which is part of the computer's USB hub. And then you can see it's plugged into some other devices. And as you go through, you're building up the tiers all the way from left to right. And as you build up those tiers, you can click on a given device, and we will show you everything we can about that device. In this case, somebody selected a Logitech Brio. You can see the USB device address, the class. It's just a very, very helpful piece of software. Anything you connect beyond tier 7, we're not going to show you, because you shouldn't be doing that anyway. There is another tool, USB Device Tree Viewer. This is a free standalone diagnostic tool for Windows. You can download it. It displays all the USB controllers in a tree layout. It's similar to what we created. To me, it's just a little bit harder to read, but it's not impossible to read. You can see the computer, you can see the host controller, the USB root hub, and as each one of these vertical lines gets drawn, you're encountering another tier. and it actually tells you the port chain, like which ports you're actually connected to. So it's a nice useful piece of software. There's that Logitech Brio that we saw in the previous slide when you're using the Lightware tool. But this is the way that you would count up the number of tiers if you're using USB device tree viewer. Free software, downloadable for Windows. You can find it on the internet or at your favorite app store. There's another USB tree viewer that comes with Mac systems. It's under the system report. It's, again, I think pretty easy to read, but I like ours a little bit better. But it's standard, so you don't even have to go download anything. If you're running your Mac OS, it's in your settings menu. Okay, now USB device classes. What we're trying to do here is introduce several different USB device classes that, in this case, are not time sensitive. That's why I've got this word non-isochronous up at the top. And isochronous, isochronous, however you want to say it. What do we mean? Time sensitive. Time sensitive. Chronos, like chronology, or chronos, the god. What we mean by time is generally 3 or 4 seconds or 5 seconds. And let me explain. If you're sending a keyboard mouse, or you're doing data transfer, or a chip card interface, or a mass storage class device, or a USB hub, several seconds are really not that important. You can get by with that. And so it's okay if one packet of data arrives 1 second after another packet of data, and then they get rearranged, or if 3 or 4 seconds go by and you've got some smart card reader or a keyboard or mouse, it's okay. What is not okay is when you get to audio video related devices, and these are isochronous. These are time sensitive devices. So many of the things that we deal with on a daily basis in conferencing, collaboration, and integrated systems are isochronous devices. And why is that important? Because frames of video have to arrive in the right order, and they have to arrive as immediately as possible. And audio, you can't get a bit of audio and then get the other one that was previously supposed to be sent 2 seconds later. It's never going to work. It's going to be unintelligible. And so for video and audio, time sensitivity is crucial. The video frames, the audio information, everything that's associated with that has to arrive as fast as possible, and it's got to arrive in the correct order. If it doesn't arrive in the correct order, people won't be able to understand it. Kind of slipped through a couple of slides there, so let's go. Transfer methods. Well, how are we going to do this? There's the USB protocol defines 4 different data transfer types, and each one is organized for a different kind of behavior, different kind of device. Control transfers. It's part of the standard. Every device uses it. The host initiates it. If you're using interrupt, that's usually for keyboards, mice, game controllers, HID sensors. And then the 2 last methods are the time-sensitive ones, isochronous. This is for large amounts of data, just like video cameras or real-time media drivers or microphones. And then finally, bulk transfer. Now, bulk can be sent at a constant rate. It can be used for flash drives, printers, scanners. It does have a video class to it. So isochronous and bulk will be used when you're transporting video for sure. Here's an example of a driver for an Elgato face cam, in which the driver itself actually gives you the choice to decide whether you want to use isochronous or bulk. You can see in that little dialog box, somebody would have to choose, do they want to use bulk or isochronous? And by default, the Windows will choose bulk, the M1 Mac is isochronous, Intel Mac is bulk, and Microsoft Surface is isochronous. So you've got some things you need to know about the way to set up if you're doing a driver-based transfer method. When we talk about isochronous, I'm going to say it again, time-sensitive data, audio or video, got to have priority. There's no correction, there's no retry, there's no delay. We're trying to get it there all in the right order immediately at a constant rate. And for those of you that are going to take the Avixa test, bulk data transfer is on the test. I took it this morning. So you want to know that bulk means reliable exchange of data, error detection and correction. Make a note about this. Bulk error detection and correction is essential. the transfer rate is secondary, and it uses the bandwidth left over from all other transmission types. If you want to take that test and pass the test, don't forget that answer. HID extension is easy because it's just small amounts of bandwidth. It's a keyboard stroke, it's a mouse, command. It's just not that much data. So we focus on bulk and isochronous because that's the world we live in. All right, we're going to talk about USB hubs and host switches for a second. What is a USB hub? Well, it expands the number of peripherals that are available to a given host PC. A lot of hosts, your PC or Mac will have a USB peripheral port. Maybe they've got two, but they're limited. And many people now have 3 or 4 or even more peripheral devices they want to connect. In this case, the hub would connect to the computer and allow you to insert more peripherals associated with that host computer. So that's a hub. A type of host switch is what we're interested in. And what is a host switch? It's basically what the name says. If I've got these peripherals, these mice, keyboard, wireless mouse and keyboard, and they're plugged into a peripheral port, we can dynamically decide which host computer those peripherals are assigned to. And if you want to change that assignment, then you can use this host switch, in which case all of these peripherals would go from number 1 to number 2, number 3, or number 4, depending on what you want to do. Inside the USB host switch, it's a mechanical switch. So you've got this connection, and then you decide, okay, we're going to switch it all to the next host. You can think about it like this. We came up with this idea to try to make it simple. If you remember these old pens where you can only choose one color at a time, if those ink colors represented multiple hosts, just like the 4 that we showed you, then you can only use one at a time, just like down here. So you can select a given host discreetly. And that is exactly what the Taurus does. If you remember back to the conversation we had about the end user that wanted to be able to allow people to walk in with their Surface tablet, this is the configuration that ultimately allowed them to do that. So you've got USB peripheral ports here on the back of your Taurus. This is the back at the bottom. This is the front at the top. And so you could dynamically say all of these USB peripheral ports should now be associated with the in-room computer until I decide differently. So there's your 4 ports for the peripherals. And there on the top, as you can see, there's your 4 different ports for your computers. So USB-C input 1, USB-C input 2, and then input 3 is actually that combined HDMI USB. And then the input 4 is also that combined HDMI USB. There is no breakaway. Once a peripheral goes into the hub, it's not going to break away. So this is not like a matrix switch for each individual USB peripheral. But I will bring up something. If these 4 ports at the bottom, these peripherals, are represented by USB-A ports, you do have the ability, using the Taurus, to individually turn on or off any given port dynamically, depending on what you want to do. That could be useful if you don't want to send a particular peripheral to a new host computer. You could just turn that port off dynamically and say, okay, that port's no longer powered, so it's not going to be available to the new host. One of the other cool things about that is you could reboot a product remotely. When we first came out with the Taurus, it was a standalone device that had limitations in terms of the cable distance because of the USB protocol data distance. But people immediately said, you know what? We want to extend USB signals. Extension was something that was a big deal, and it's not easy. And so we had to do a lot of research about what kind of technology we were going to implement, what kind of signal processing we were going to allow, because just extending USB 2 and USB 3 is not quite as easy as it sounds. It's actually one of the biggest challenges we've got in the AV industry. Lightware itself did research, and we looked, of course, at HD-Base-T because we've got a great relationship with those guys. We looked at Icron, who is known in the business for being the gold gold standard for USB extension. And then SDVoE, which is software defined video over Ethernet. That's the 10 gigabit backbone for Semtech chips that has been around for quite a while for video delivery, audio video delivery. When you're extending this slide, so this is kind of the decision that people were forced to make years ago, which was, hey, if we're going to have this extension, they usually would just extend the AV separately. So they might use some HD-based T receivers or transmitter receivers from somebody, but they would take the audio, the video, separate it out, extend it separately, and then extend the USB on its own. So maybe they would use some Icron extenders or something like that. That was the way it was done before extension became really widespread. We and other people have decided to give a single cable for that extension requirement. And so that's why it was really important. People don't want to run two cables. They want to run the minimum number of cables required. But in order to do that, we've got to combine audio, video, and USB by using signal processing. And that's the way that we can get everything down to one cable. And we do that by our partnership with Icron and SDVoE so that we can process those signals and also move them 100 meters. This is about your transmission modes. There's basically two keyboard and mouse transmission modes. We're not talking about video here. We're talking about HID delivery, human interface device. And so that could be mice and keyboards or a touch screen, but there's two different modes. Transparent, which is where the extender shows these devices to the host exactly as they would appear. There is no processing going on. Because there's no processing going on, they have to interact directly with the operating system of the host, and you can get those dings or sounds when they're connected or disconnected. There's another function, which is, hold on, wait for it, emulated composite mode. This is for HID class only, and what we do is we emulate a keyboard and mouse, and we present that to the operating system so that it always sees it. And since it never loses its emulated keyboard and mouse, you don't hear the annoying dinging as it's switching between hosts. Here's an example of the way transparent mode would look to transmit receive design. Each of those keyboards are going to be sent as they really are. They are fully preserved. You will need a driver. And when the Logi is touched, that Logi device is going to appear to the transmit to the host exactly as a Logi device, because it is truly going to be there transparently. When another keyboard is selected, it's going to identify itself as that type of keyboard to that operating system. What we do is called emulated composite mode, where we are maintaining the connection, one persistent Lightware USB HID device that emulates the keyboard and mouse. And because it's never disconnecting from the host, it makes it much more smooth. It's faster switching, it's a smoother user experience, and that's why we've chosen emulated composite mode on the HID surface. All right, I'm going to pause for 1 second, go to my friend Tyler, ask him if he's got any questions or things that we want to take up right now before I continue. So, Tyler.
So I was kind of answering some of the questions. Let me go back. One, I was actually just responding to
Okay.
when devices go to the tier 7 of like the USB hub. Occasionally you'll see some signs of life out of it, but most of the time the USB peripherals won't function when they kind of go to that 7th tier and above. So just wanted to answer that.
Okay.
Um, Let me look and see what else. Um, we did see a couple of questions about the USB tree uh
Mm-hmm.
application that was also
Mm-hmm.
dropped in the chat as well.
Great.
I think that is about it for right now.
Okay, that's fine. I just don't want to get too far behind in time or questions. So let's keep rocking and rolling, okay?
Yep.
Okay, thanks. Um, USB-C, for our purposes, this is the cable that we want to have rule them all. It can replace all those other formats for connection, like we talked about. And we all know how important cabling is to any kind of environment. This is the physical layer. This is where connections happen electronically, data-wise. It's you've got to have a foundation. You got to have a good foundation, or nothing's ever going to really work. One of the things about USB-C is, remember, that is the connector type. That is easy connectivity, easy mating, a symmetrical plug and pin layout, identical cable ends. You can use one or the other for the host or the peripheral. Both ends can be data, power, source, or sync. It's very slim and sleek. You've got this one that's actually got a locking connector on the top. We've got a locking connector sleeve of our own that we sell. They have been tested for up to 10,000 mating cycles. They're backwards compatible and actually support up to 240 watts of power. We're actually just about to introduce a cable that supports 240 watts of power. The devices themselves will not initially, but ultimately we will. And right now we support 60 and 100 watts through our products and cables that are about to support 240 watts on USB-C. When we talk about USB-C, one of the things you want to really keep in mind is full featured. And full featured means that we are able to use both the super speed lanes and the high speed lanes. Let's go back and we'll do a little review. On high speed, that was our USB 2.0 data transfer up to 480 megabits per second. And that was a half duplex communication, but it is in the full featured capabilities of this USB-C connector and cable. Super speed data transfer was added, and it gives you 4 pairs of pins, 2 full duplex channels, so you can get that 5, 10, and 20 gigabits per second for USB 3 data transfer. What's interesting is some of these data transfer, features will be used for different things at different times. It's dynamic, and so you really do need both in the cable to be able to access all that stuff. There's some sideband use, configuration channel for configuration between the devices, and we're going to keep going. The capabilities in Pro AV are HDMI, USB, Ethernet, and power, all aggregated. I'll say audio and video when I say HDMI, audio and video, all aggregated down to that single USB-C cable. This is really powerful. Remember, we talked about extension, how we didn't want 2 cat cables. Well, we also don't want a handful of cables plugged into our source, our host device either. The fewer, the better. And so now we've got audio and video, USB data, and charging. We're able to charge that host device, 60 watts or 100 watts or 120 watts, I think, even on some models. But you need a full featured cable to be able to do that. So in your notes there, please write down full featured. You're going to want to remember that full featured USB-C cable. One of the most basic uses of the USB-C standardization is really to simplify power delivery. And that was one of the big reasons, like I talked about, that USB-C was brought into existence and became such a prevalent connector. The power delivery is a basic part of the USB standard. There's a power delivery protocol negotiation. It's a little bit like EDID in that the source tells the peripheral, hey, this is what I'm capable of. On connection, the USB-C cable will connect and the default power begins at 5 volts. But the source it advertises its capabilities and says, hey, can you send me 60 volts? Can you send me 160 watts, 100 watts? And then the sync chooses the power level. So once you get that requested data object, the contract is established and the power is delivered. This is more about the power data object and how it defines the capability to deliver the power. Like I said, in the standard, you can get up to 240 watts, but this slide is really about the negotiation going on between the host and the source to sync connection. So first it's got to establish the connection. Then it says, wait, I support 5 volts at 2.4 amps. or 9 volts at 3 amps, or 20 volts at 3 amps. And so based on that communication and protocol, they will negotiate and figure out how much power can be sent. And it's actually a very, very useful feature. One of the things that people really love about USB-C topology. Okay, now data delivery. This is going to be about bandwidth growth. We're going to dig deeper into what defines a USB-C type cable and look at all the elements supported by this connection, including DP alt mode, USB and USB 2 and 3, power delivery, and Ethernet. You've seen this information now several times, and we're showing it again because it's so important. At the top, you've got this USB super speed data. Those are the transfer lanes for 5, 10, and 20 gigabits, USB 3. Then you've got your high-speed data transfer, USB 2, 480 megabits per second, which you want all of. But the USB data transfer can happen on the 2 layers simultaneously. It's very interesting. So all of those data transfer lanes are being used when you're transferring different types of applications. The slide shows you the super speed data transfer pins and the high speed data transfer pins. You will get a copy of this presentation. You don't need to memorize this. Just remember that there's full duplex for USB 3 and super speed data, and half duplex for USB 2. This slide, just a little bit more about what USB 2 is used for in terms of webcams, USB audio, Ethernet, and HID, and your mass storage at 480 megabits per second. And if you're going up to USB 3, then you will use those lanes and all the bandwidth that they can give you with the cable that supports it, because it's a full-featured cable. Conversion of USB 2 to USB 3. So people would originally say, wait, but I just want to extend my USB 3, because I've got a camera that supports USB 3. If everything is USB 3 in that connection from the hub and the host and the transmitter and everything, you can get that, but it is not easy. The physical wires are different. Remember that. USB 2 uses that differential pair for half duplex. USB 3 uses the 2 additional differential pairs. So you would have to actually change your signaling method. The protocol layers are different. The timing model is different. A converter would essentially have to terminate USB 2.0 and then recreate USB 3 from scratch, which makes it a full USB bridge. It's just not easy, as you would think it could be easy, but it's not. There was an adapter that's been created. It's a proprietary solution by Biolabs. It's used in active optical cables. The USB 2 is bidirectional, but it doesn't have dedicated transmit receive channels, which makes it hard to extend. So the layer conversion can be used, but needs to be tested. And if you're going to extend USB 3, make sure you connect it to a USB 3 port. How do we deliver video over USB-C? So on the left-hand side of this slide, you've got the DisplayPort pinout. That's the DisplayPort connector with the data lanes that are associated with delivering DisplayPort video. But then we can use a USB-C connector to deliver what we call DisplayPort alt mode. And DP alt mode uses the USB-C lanes to deliver DisplayPort video. What alternate mode does is it takes those USB data lanes and it uses them to send DisplayPort video. Super speed, high speed lanes are changed from their normal uses. You've got those pins, 12 pins for the main link, 4 shielded twisted pairs, 2 pins for the wires, 3 pins for the aux channel. But once this is negotiated, this cable effectively becomes a DisplayPort cable, even though it's got a USB-C connector. When you're doing DP alt mode, it depends on the amount of bandwidth that you need, and that is something that's got to be negotiated. It depends on the kind of video that you're sending. You can have 2-lane DP alt mode or 4-lane DP alt mode. If you're using 4-lane DP alt mode, because you're using those extra pins, you're not going to be able to get USB 3 also, because now you're using all of that functionality for video. If you're using your DisplayPort up to 4K 30, then you still have those USB 3 pins left over, so you can send that USB 3 data along with your 2-lane DP alt mode. One of the main things to remember here is that when you're setting up a system, you'd love to be able to choose whether or not you have to have 2-lane or 4-lane. And yes, Lightware does. Lightware allows you to choose 2-lane or 4-lane in our devices. When two-lane DP is offered, most devices will choose two-lane DP alt mode. That's just the pretty much standard. But you really do want a device that allows you to choose between two-lane and four-lane mode. This slide takes us through the DisplayPort standard over there on the left, so you can see what bit rate we're running. And then in the middle, that central orange header slide is really about the DP alt mode, two-lane or four-lane we were just talking about, and what amount of bandwidth is required because of the signals that you're trying to send, whether it's compliant with two-lane or four-lane. And then finally, on the right-hand side of that slide, under the blue heading, are a refresher on the data rates, the USB super speed data rates. Again, you'll get a copy of this information, so you don't need to memorize it. Okay, we're going to talk about cabling for a little while. I mentioned it earlier, but from the OSI model of networking, the physical layer is cabling. And when you're extending signals, the physical layer can become a limiting factor. Things like insertion loss, impedance mismatch, or jitter, or skew between differential pairs, all those things can come up when you're extending signals. When you get to higher bandwidth, you need shorter cables, as you can imagine. And cables is what makes all this stuff talk to each other. There's cables between everything. A wide variety of cables necessary for a UC room to function. You've got your USB-C to C with your host cables. You've got extender cables that might take maybe a USB-C or A to C, or even an A to a B. It's just an alphabet soup of different kinds of USB connector types. And this is a good example of all the different types of cables that you could potentially need in order to create a successful system. I like this also that they've included the Icron host data extension in that green line over there on the left. So incredibly important. We've got a lot of cables to make the room work. We want to make sure we get the right kind. And we're lucky because we get to charge with the cable that we connect from USB-C. When we talk about USB-C cables themselves, you cannot tell what is going on with the cable by looking at the connector. I want to say that again because it's so important. When you connect your USB-C, that does not tell you what is going on in the cable. You need a full-featured cable to get all that 2.0 and 3.0 speeds. USB-C cables for power are cheap and available, but they will not carry the full complement of USB protocol. So use a full-featured cable. I highlighted that in yellow in the middle for those of you that are taking the test. That's a clue. Look at that full-featured USB-C cable requirements because that'll be on the test. And you've got some other optional USB features like Thunderbolt as well. When we're doing this, some people want to use patch panels or extender cables, and the answer is maybe. Maybe it's a good idea, maybe it's not, because you don't know necessarily how that patch system was designed. If that patch system is not designed properly, it could break DP alt mode, it could break USB 3 data. So it's something you have to test, and you've got to test it with your USB 3 devices if that's what you're planning on doing. They also add insertion loss. It can degrade the pattern. It could degrade the signal. If you're using a patch panel or an extender cable and it's not doing well, you will see things like intermittent video, screen flickering, link training failures, resolution dropping. So we just don't recommend it if you're using DP alt mode for extension, which we are, because they can degrade the signal. So it's just, if you can avoid it, please do, or if you're going to do it, you need to test it. This is a list of some of the Lightware USB host cables. So you can see we've got some copper cables in different lengths. They say meters, but you can do a quick ×3 and figure out how much that is in feet. We got some very flexible, nice micro coax cables with 100-watt charging capability and 60-watt charging. And then the active optical cables. What we mean by active optical is that we're actually doing some signal equalization, some retiming, some redriving, some signal amplification. We've got a protocol conditioning circuitry in there where we're doing something to the signal. That's why it's active. But we are allowing you to extend 8 meters and even 10 meters. 10 meters, it's a good distance. If you're going to do USB peripheral extension, there's another set of cables that you can get, USB A male to C male. And many times you want this because the peripherals at the front of the room and they need to be extended back to the hub, the Taurus or the host computer. And so you need some of that extension topology to get stuff from that's at the front of the room to the middle of the room. If you really have to get fancy, you can also do a dedicated extension via Cat6 cables. We have those devices from Lightware USB 2.0 extension. If you've got to extend USB 3, you can take a look at things from a company called Icron as well. Another example of some active extension cables in long lengths, 10 meter and 16 meter. That's almost 50 feet. So USB 2 and USB 3 extension with these cables, also able to send power. So nice little feature on there. There are other options if you have to have dedicated extension. We've got some options as well. Some other companies do two. This is an extension of USB over Cat, and then the Icron Ranger are in there as well. And now, finally, the Taurus in all its incarnations. We're going to jump in and see what types of Taurus models we've got. We're going to run through this to try to keep it to just a little bit over an hour, but here we go. Originally, the Taurus was developed as a standalone solution. And so in this graph, what you're seeing on the left-hand side is when everything is within cable length. So your host is within cable length and your peripherals are within cable length. Then people said, wait, we want to extend things. I've got things at the front of the room and I want to extend it back to the center of the room where my hosts are. And so we came up with the point-to-point Taurus. And so now you can have that extension with a transmit-receive topology. And then finally, the networked version, which requires a 10 gigabit Ethernet switch in the middle, but allows everything to connect to everywhere. So any peripheral plugged in to a remote site will be available to any given host. It's a very, very powerful application. And that's the reason we say we've got a Taurus for that. We have a Taurus for that because whether you're doing standalone, point-to-point, or networked, different use cases, different topologies, different technologies. If we look at the beginning of the way this thing works, there's a Taurus. This is the model that's a standalone model. Again, that's the front on the top and the rear on the bottom. You get all this stuff, the audio, the video, the USB 3, the LoRa automation, the fast charging. Oh, LoRa automation. There is a control system built in. And so actually, let's just take a look at the Taurus itself so you can see what I'm talking about. But we've got the front and the back. At the top, those are our inputs for our source computers. 2 are USB-C enabled, and then 2 more have the combined USB and HDMI. For some older style laptops, you could put your dedicated computer there. In fact, if you wanted, you could put a Barco receiver there because those are just inputs to the system. There's a 4-port USB-A peripheral hub built in. That's our 2 HDMI outputs. Those are independent. So any given signal that's in the system can be sent to any one of those 2 outputs. There's a built-in configurable Ethernet switch inside the Taurus that's used to be able to route deterministically where your Ethernet signal goes. That could be go out to the guest network. It could be a way for somebody to manage and monitor the Taurus remotely from the supervisor's network. You could use Ethernet to control devices in the room, and that's where you would do it. This particular device also has a 2-channel Dante audio out, so you could send that Dante out to your Dante network. There is also an analog audio out that's a de-embedded from the content on the HDMI signal. Because it does have a control system built in, there's a couple of RS-232 ports that you're going to use with your LoRa programming and to control things, TVs, whatnot. The occupancy sensor input. So let's say you wanted the room to behave in a certain way. If the occupancy sensor went high, saying somebody's entered the room, you could turn on the displays, right, with that control signal. You could then switch to an internally generated welcome screen so that instead of having that laminated PDF on the table, you could actually use the display in the room to tell people how to connect and what to expect. There's GPIOs available for lifts, shades, drapes, things like that, and a couple of service connectors, and then some input selection buttons if you really, really need to put your hands on the device, and a power connector. The Taurus Extender series extends USB data as USB 2.0, but we're also extending Ethernet, video, audio, and control. You've got the transmitter close to your bring your own meeting devices. and then you run a Cat6 cable to the receiver by the display and the peripherals. And so those peripherals will plug into the receiver. It's a very common use case that those cameras, microphones are all at the front of the room, so you extend back to the users in the middle of the room, and that's your TPX point-to-point solution from Lightware. There's a variety of different transmitter styles, and mainly around the number of inputs that we support. So there's 2x1, 4x3, and just so you know this nomenclature, a UCX 2x1 TPX is the extension version, TX is the transmitter, and then you've got the RX for your receivers. I will call your attention to that one little receiver way down in the bottom right-hand corner. That's the scaling receiver. Really useful if you want to be able to normalize your video to scale and to a scaled output. This is one of my favorite Taurus that we developed, and I just think it's so cool because of what it does with the audio. You know, a lot of times we get very focused on the video, but without audio, nothing moves forward. And so what the Bridge Dante Taurus does, it allows for a seamless two-way audio communication between Dante audio devices and any other format of audio, including USB and analog. So that's why it's called a bridge, because we're actually bridging between USB audio that's coming in, the analog audio that's coming in, and the Dante audio that could be coming in or out. And so you could use a Dante-enabled microphone in the room as an audio input for the soft codec. And it's interesting because the way that the Taurus connects to the host looks at the Taurus as a USB audio device, as kind of a sound card, actually. And that also gives you a chance to name that particular input on the USB side. So kind of a really interesting way of using Dante. Dante's a big deal. We're big fans of Dante, and I know there's a lot of people out there that want to use it. And so now, if you wanted to, you could use this. There's actually a DSP built in to the bridged Taurus. It's a small DSP. I'm not saying it's reliable for a concert hall, but for a small room, you could definitely use that DSP and enjoy the output. There is a feature in many laptops these days that is called extended desktop or dual HD display. What that means is that the source laptop could be able to support two separate distinct high definition displays over a single USB-C cable. We created this Taurus specifically for those types of devices. I'll show you another slide that'll kind of give you an idea of what I mean by this, but this was a really, really important development for Lightware. There's a lot of people out there that want that ability to support two separate distinct displays from their source device. And using that single USB-C cable, this Taurus model is able to do it. Here's a little bit different way to think about it. If you think about whether you're mirroring or extending or switching between, your support on the device, you've got mirroring on all Taurus products. So if you see that on your laptop and it can get out, then we're going to show that mirrored. If your laptop can support an extended desktop, then that's what we're going to show, and you can decide which desktop you want to show, but you show that, and that is mirrored across the next output. And then finally, there's the ability of your computer to support dual screen extended desktop, and that's what the HCM40 is all about. We talked a little bit about the networked version of Taurus. And so the most common use case for something like this is a divisible room. Imagine you've got two separate rooms. They're using two different USB cameras when they're separated. Now the wall comes down and the new host wants to connect to the camera in the other room. And they can do it because they're all on the TPN version of Taurus. So it's a networked version that allows you to dynamically assign which hosts are available to which peripherals and vice versa, and you can do it in a networked fashion. So anything is available to anything, anywhere. In the Taurus TPN networked version line, there's a variety of different transmitters, different receivers. You can see some examples here. If you have any questions about these, please contact your Lightware representative and talk about your designs. He'll be happy, or she'll be happy to help you walk through it. And so I'm closing up. We have a Taurus for that. It could be local. It could be point to point. It could be networked. You want to come take a look at it. We'd love to talk to you about your designs. Tyler will drop that link in so that you can do your quiz. Get that quiz done within, I think it's within a couple of weeks. I want to say it's like by April 17th. But get it done with above 7 out of 10 questions right. You'll get your certificate of completion from Lightware. You could submit it to Avixa for your credits. You get your 1 credit. And I am done. Tyler, anything we should address to the group, or are we good?
I'm pretty sure the questions that were asked in the last couple of minutes were answered with your last few slides. So
Okay.
I think we're good with that. Did see about 5K as of last fall. Yeah, that is supported on our devices. Yeah, I think everything else was answered.
Okay. Well, look, they're going to get the materials, right?
Yep.
So they'll get access to the recording, get access to the PowerPoint, so they can review it. Thank you guys very much for joining. Really appreciate it. Have a great afternoon. Have a great day. Please give us a call if you got any designs in mind. Thank you very much. Take care, guys.